Welcome to a short video on dilution. You've all diluted stuff before. Take a look at this Minute Maid concentrate. Oh, concentrated, yeah. So there's a whole bunch of stuff packed in that little can. And so what you're going to do is you're going to add a lot of water to dilute it. That's basically what dilution is. So if you can see on one side you have this extremely faded pink, and on the right side it's dark. Well, in order to get from a very concentrated solution into a diluted solution, you just add water. The interesting thing is, when we do dilution, we measure that in terms of molarity. So if we look on the left side, you've got a very concentrated solution as indicated by the dark color, and it's a 100 molar solution. Wow, that 100 molar, that's concentrated. And each time it gets decreased. Your concentration gets decreased. And how do we dilute something? Well, we add water. That's pretty much all there is to it, is adding water. Now take a look at this. On the left side I have a stock solution, and in your stock solution you'll notice it's a ratio. Remember, molarity, it's a ratio, moles per liter. So here I have 1, 2, 3, 4, 5, 6. Yeah, you can't see me tap the screen. But you have 6, we'll call it 6 moles of solute. And however much, we'll say this is 10 milliliters because that's pretty easy to measure. When we add the water, notice that I still have 6 moles of solute over here. That didn't change. But what changed was the amount of water. So now say I have, we'll call this 30 milliliters of water. So the molarity on the left would be 6 divided by 10, which is a 0.6 molar solution. But over here we have 6 divided by 30, which is a 0.2 molar solution. And we all know that 0.6 is greater than 0.2. So simply by adding water, we've diluted the solution, we've lowered the concentration. The number of moles does not change. So we're going to use this handy dandy formula that you absolutely need to memorize. M1V1 equals M2V2. So where M1 is your initial molarity, V1 is your initial volume, and then your final molarity and your final volume. See what I did with the colors? I diluted those? Yeah, I know, it's too much. Okay, so the interesting thing, this equation works because the number of moles does not change. That's why we can do this equation. Won't change. So here's an example problem. What volume of a 16 molar sulfuric acid must be used to prepare 1.5 liters of a 0.1 molar sulfuric acid solution? Oh boy. Well, I like to get rid of all that word crap and just put in the numbers. The critical thing to remember is you have to keep those two together. We're solving for V1. If you mix them around, say you get M1 with V2 and you get M2 with V1, you are going to get the wrong answers. So make sure you're kind of doing a reality check as you do these problems. Okay, I like to set up the problem here where I'm going to get M1, V1, M2, V2. You can substitute now and do the algebra. I like to rearrange now, and I'm going to divide both sides by M1. So I end up with V1 equals M2 V2 over M1. Plug my numbers in, so M2 is 0.1, V2 is 1.5 liters, divided by, now we need M1, which is 16. Okay, I had to get my calculator. So, okay, 0.1 times 1.5 divided by 16. So we need 0.00938 liters. That's awkward. I think the key thing here is we really have 9.3, well, if I'm going to pay attention to sig figs, 9.4 milliliters of solution. Okay, what does this mean? All right, what we did was we had a stock solution that was extremely concentrated. So I'm going to make a little container here. It's not a great container. It's a really bad container. I gotta try this again. Okay, we're not trying any kind of fancy container. We're just container. Okay, and in this container, I don't even know how much is in here. It doesn't matter, but the label says it's a 16 molar sulfuric acid solution that is super concentrated. For a lab, what I need for the lab is I need a pretty diluted solution. So I need to take one of those volumetric flasks that I showed you the other day. Another bad drawing, but artist I'm not. There's your little etched line. And we're going to pretend that I can make or found a 1.5 liter volumetric flask. So I'm going to put in a little bit of water. And the reason I'm going to put in a little bit of water for this is there's a rule that says you always add acid to water. Never the other way around. It's extremely exothermic when you do this. The water is going to get super hot. And if you put the water on top of the acid, you can actually get burned. So don't do that. You always add acid, add acid to water. So I put a little bit of water in there. And the question is, how much of this do I need to put in there? And that answer we found out. I need to take 9.4 milliliters. So I'm going to first take, let's get a different color here. I'm going to take a graduated cylinder. Ideally, you might want to actually use a pipette. But I'm going to take a graduated cylinder and fill it up to 9.4 milliliters. Then I'm going to take this and put it into the water. Then I want to take some, like a distilled water container, and I'm going to rinse this out several times and pour it in so that I make sure all 9.4 milliliters of the sulfuric acid gets into the volumetric flask. Once I'm sure this is completely rinsed out, then I'm going to add more water to this until I've reached the etched line. Now I know I have 1.5 liters of a 0.1 molar solution. Okay, let's try a new one. Calculate the new molarity when this many milliliters of water is added to that many milliliters of hydrochloric acid. So we need a new molarity, so I'm going to call that M2. I'm going to take 125 milliliters of water and add it to 125 milliliters of this. So V2, M1, V1. We know that M1 is given to us as 0.251. Our initial volume is 125 milliliters. V2 is a little tricky because I'm adding this much water to this much water. So my total volume is going to be 250 plus 125 milliliters. So that's going to give me 375 milliliters of water. And you're just going to use your formula, M1V1, M2V2. I'm solving for M2. So I'm going to rearrange this equation to M1V1 over V2. Plug in our numbers. M1 is 0.251. V1 is, and you can leave this in milliliters. If this is in milliliters and that's in milliliters, you're fine. As long as your volume units are the same, you're good to go. Our second volume then was 375. Get my handy dandy calculator. 0.251 times 125 divided by 375. 3 sig fig, 0.0837 molar solution of HCl. Which then you want to ask yourself, did this make sense? We started with a 0.251 molar solution. We added water, so did the molarity come down? And in this case, the answer is yes. Yes, it did. Pause the video at this point and see if you can figure out the answer to this one. Okay, so M1, V1, M2, V2. We need the new molarity. When 250 milliliters of water is added to that many milliliters, so 445 milliliters, M1, 0.499, and V2 again, we have to add both of these, so 445 and 250, 596 milliliters. Our equation, M1 V1 equals M2 V2, solving for M2, M1 V1 over V2. So M1 is 0.499. We should really put units in there. V1 is 445 milliliters divided by 695 milliliters. Milliliters drop out. Okay, let's give it a go. Oh, that's my phone, not a calculator. Okay, here we go. 0.499 times 445 divided by 695. 0.320 M. Did the concentration go down when we added more water? And the answer is yes. Yes, it did. This is very similar to that first problem that we did. So let's write out what we have. M2, V2. M1 is 16. V1, we don't know. But we know at the end of this, I need a 0.10 and 1.5 liters. Give it a try. See what you can solve. So M2 is 0.10 M. V2 is 1.5 liters. M1 is 16 M. Calculator. Alrighty, 0.1 times 1.5 divided by 16. I thought that was the same problem. 9.4 liters or 9.4 milliliters. Either answer is fine, just watch your sig figs. What volume of sodium hydroxide do we need? So go ahead and pause the video and see if you can solve this one. I like to take inventory, so I know M1 is 19. V1 we don't know. M2 is 0.15 and V2 is 1.0 liters. So let's write our equation, M2, V2, solving for V1. So then we end up with 0.15 times 1 liter divided by 19 molar solution. So 0.15 divided by 19, 0.00, oh, my phone rang, hold on, 0.0079 liters, which is equal to 7.9 milliliters. Which makes sense.